Hi guys, let's talk about partial fractions today. So partial fractions is one of those methods that we use to find an integral. Okay, so for step number one, let's recall some things. For example, we need to know how to solve system of equations before we do partial fraction method, and also how to subtract fractions. Okay, go and have a look at those two topics if that's something that you can recall. Okay, and second, we will be talking about the method itself and having a look at an example with the method. And the third step is having a look at some complex cases where this gets kind of more challenging to solve. Okay, so let's have a look. Partial fraction. So get the cursor working. 1 second. Okay, so let's say we were told to find an integral of 6 over x minus 2 times x plus 4 dx. As you can see, it gets kind of difficult to solve this, and we kind of need another method, and partial fractions has come for the rescue. Okay, so what do we do? First, we gotta divide this into two fractions. And how do we do that? We don't know the number yet, what this number is gonna be. We're gonna let that number divided by x minus 2, okay, plus, okay, another number, we're gonna let it be equal to b, and b over x plus 4 dx, and we're gonna find the integral of both this plus that. Okay, now next step is to multiply x minus 2x plus 4 to the top, to each of these three fractions that we have right now. Okay, so we're going to be left with 6 equals, if we multiply x minus 2x plus 4 to this a value, we're going to be left with x plus 4, and if we multiply that to b, we're going to be left with x minus 2. Okay, since it already has x plus 4. Okay, next step is to say what happens when was to try to isolate one of these. Is try to corner down A or B. Let's start with finding what A is. Okay, to do that, we gotta kind of cancel a B. How do we do that? We're gonna let x equals to 2. Okay, so let's say x equals to 2, then 6 is gonna be equal to 2 plus 4 is 6, A. Okay, and b is going to cancel out because it's going to be 0, right? Plus b times 0, which is going to be 0, right? And we're going to find out that a equals to 1. Now, if we let a equals to negative 4, right? Let's see, because that's what's going to cancel out the a, right? So a equals, so let x equals to negative 4, right? Sorry, x equals to negative 4, it's going to be 6 equals. Negative 4 plus 4 is going to be 0, so it's going to be a times 0 plus negative 6. Negative 6b. Okay, we're going to be left with 6 equals to negative 6b. Divide negative 6 both sides. We're going to get b equals to negative 1. Okay, so now we have both our a and b values, guys. The next step we got to do is plug it back into this. Okay, so plug it back into that. So we're going to be left with finding the integral of 1 over x minus 2 plus, what is our b value? Negative 1. So we could just say minus 1 over x plus 4, right? X plus 4 dx. Okay, now we can do normal integration. Let's divide this into two separate integrals. So 1 over x plus 4 dx and 1 over x minus 2 dx. If you recall, integral of du over u equals to ln of u plus c. Okay, so that's all we're going to be doing here. We're going to let x minus 2 be equal to u. Okay, so let that be equal to u. And du is just going to be dx. Okay, so it's just going to be dx. So what our answer is going to look like, actually, we find the integral of this, right? So it's going to be ln of absolute value of x minus 2 minus natural log of x plus 4 plus c. Alright guys, that is our answer. And if you have a look, that's how we do partial fraction method basically. Okay, now let's have a look at some specific complex cases. Okay, say we have linear factors. Okay, so we have linear factors in the denominator, factors in denominator, right? So what are we gonna do in that case? Okay, so let's have a look at an example to see what we're gonna do. Say we've given to find the integral of 9x squared plus 2x minus 1 over x minus 1 times 2x squared plus 7x minus 4 dx. Okay, so let's see what we're going to let our a equal to. So we're going to let our a over x, we're going to let it be equal to a over x minus 1, since that's what our first fraction is going to look like. And the second part of our fraction is we got to factor out. We got to factor out our, this looks like a quadratic, right? So let's see if we can factor that out. So 2x, x, that could be negative 1, right? Negative 1 and 4, does that work? Negative 1, 4, yes, that does work. So this is our factored form of this quadratic. Okay, so so it's going to be b over 2x minus 1, okay, plus c over x plus 4. Okay guys, that's what our three fractions are going to look like. Alrighty, so we got our three fractions. Okay, three fractions. Now let's multiply all these three. So left hand side, it's going to cancel out everything. So we're just going to be left with 9x squared plus 2x minus 1. On the right hand side though, since we have three fractions, so we're going to left with a, leaving the x minus 1, it's going to be 2x minus 1 and x plus 4 plus b of, so we're going to have the other two fractions, x minus 1 and x plus 4, and c x minus 1 times x minus 1 times 2x minus 1. Okay, since those are the other two fractions when we multiply it. Now let's see what we can equal our x values to, so that we can find out. So let's figure out that our zeros over. So since we see x minus 1, let's just let our x equals to 1 so that we can cancel out that 1 minus. Okay, so when we plug in for x equals 1, it's going to be 9 minus 2 minus 1 equals to a of 2 times 1 is 1 minus 1, that's going to give us 1. 1 plus 4 is going to give us 5, plus 1 minus 1 is going to give us 0. So this is going to turn into 0. And this also, c will also turn into 0 because of the x minus 1. Which when plugged in with 1 is going to turn the whole thing to 0. Right guys? 9 minus 2, 7. 7, 7, remember this was plus, right? Sorry, that was plus. So 9 plus 2, 11, and 9 plus 2 is 11, 11 minus 1 is 10. Okay, so it's going to be 5a. So our answer is going to be equal to 2. A is going to be equal to 2. Next step, let's look at this, and we could let x equals to negative 4. Okay, let's let our x equals to negative 4. Okay, x equals negative 4. So negative 4 squared is going to be 16. 16 times 9 is going to be 144. 144 plus 2 minus negative 4 is going to be negative 8 minus 1 equal to, now if you plug in negative 4 into this, if you guys look at that, that's going to turn the whole thing to 0. Negative 4 into this, going to turn the whole thing to 0. But negative 4 into this, that's going to give us c times negative 5 times negative 9. Okay, so what it's going to give us is 135 equals to 45c. C is going to therefore be equal to 3. Alright guys, now let's find our last, we gotta find the b value. So let's let, since we have 2x minus 1, okay, if we let that equal to 0, so x is gonna equal to 1 over 2. Okay, x is gonna equal to 1 over 2. So let's let x equals to a half. If you do let x equals to a half, so it's gonna be 9 1/2 square, which is going to be 1/4, plus 2 times a half, which is going to cancel out, minus 1. Okay, so if you look over here, this is going to cancel out. 2 times a half is going to give us 1. 1 minus 1 is going to give us 0. So it's going to be 0 plus b 1/2 minus 1, 1/2 plus 4. Okay, and c is going to cancel out because of that 2x minus 1. Okay, so 9/4 plus 1 minus 1 equals to b. Half minus 1 is going to give us negative 1 over 2. Okay, half plus 4 is going to give us 9 over 2. Right, guys? Now, therefore 9, it's going to be 9/4. Since 1 plus 1 minus 1 cancels out, it's going to be 9/4 equals to negative 9/4. B is therefore going to equal negative 1. Phew, it's a lot of work, but we found our values, right? That's a big part, okay? Now that we find our values, we're going to find, cursor, please come back. Okay, integral of a, so what is our a value? A is going to be 2 over, let's go and have a look at our original integral. 2 over x minus 1, oopsies, 2 over x minus 1, plus b is negative 1, so we're going to let that equal to minus 1 over 2x minus 1, and c is going to be plus 3 over x plus 4. Okay, now it's as we were solving the integrals, this is just going to be 2 ln of x minus 1. This is something you'll see a lot of natural log in these types of problems, and the more you do, you'll just be able to just go with the flow without having to break it into separate integrals. Okay, so it's going to be 2 natural log of x minus 1 minus natural log of 2x minus 1, absolute value of course, plus 3 natural log of x plus 4 plus c. Do not forget the plus c, please. Okay, guys, so that is our final answer. I hope you have gained a firm understanding of partial fractions through this video. In the next video, we will go over a couple of more complex cases. For example, repeated linear factors. What do we do when we have repeated linear factors? When we have repeated factors, right? When we have quadratic factors, okay? And when we have denominator degree, when it's not larger than the numerator degree. Okay, so a couple more cases in next video. Hopefully, stick around as we complete this lesson on partial fractions. Thank you so much. If you did like, please like, share, and subscribe to my video, and follow me on LinkedIn also for more information. Thank you, guys.